हेलो, क्या कह रहे हैं? Hello everyone, welcome to PW. Good evening everyone. Please let me know by writing in the comment section whether audio and video everything is perfect or not. Please let me know by writing in the comment section whether audio and video everything is perfect or not. Please let me know by writing in the comment section whether audio and video everything is perfect or not. So till now we have completed a very important portion because of some technical glitch now. The entire starting get stuck. So please let me know once again. Everyone please write in the comment section beta ji and just let me know by writing in the comment section that audio and video everything is okay. Perfect. Thank you beta ji. Now please observe what we are going to study today. Very important day. Why? Because this is your lecture number 6 and in this lecture we are going to discuss a very important part, that is multiplexer and demultiplexers. So today I am going to cover multiplexers, demultiplexers, advantages, disadvantages and their application. Every year almost CS or instrumentation or your electrical and electronics, all 4 branches always get at least one question from the multiplexer part. Most of the time multiplexer has been asked. Is it okay? So this is a gate or a you can say for all competitive exams, this is a very hot topic. Mostly they are going to create question from this. Is it okay? I know most of you have still focus toward your study and there is a lot of doubt in your mind, but one day your effort will shine bright. There is no doubt in this because you chooses not to quit the fight. So it's very important. Those who just quit the fight now, stop their ongoing lectures, don't finish the entire syllabus. It's difficult for them. But those who started and move ahead, definitely one day they are going to create a history. Okay. So let's come back. Just keep this in your mind that efforts are never going to be waste. So let's come back to the very important part, that is multiplexer. So please write down multiplexer. Please write down multiplexer. Hi Munish. Beta ji, please let me know by writing in the comment section that audio and video everything is going perfect. Great. Audio video perfect. Great. So now please observe, first of all, combinational circuits. Combinational circuits, and in combinational circuits we are talking about multiplexer. So what is so important about multiplexer? Multiplexer is a combinational logic circuit. I am moving now little bit faster. The notes will be provided to your telegram, that is Varun sir PW. Okay, so I am moving little bit faster. You can note down you can make short notes and be attentive to understand the entire multiplexer and demultiplexer in just one lecture. Okay, so it is a combinational logic circuit designed to switch one of the several inputs to a single common output, also called as many to one circuit, because it has many input and only one output. Is it okay? So it has many input and only one output. Depending upon select or control, one of the input is transferred to output. Depending upon select or control, one of the input is transferred to output. It is also called as data selector. Also called as data selector, and it is a universal logic circuit. Now let's try to understand how a multiplexer will function. If you compare a multiplexer with your basic suppose remote control with your multiple channels coming as an input signal to your TV, but only one signal is going to displayed over your LEDs, okay, that you can see onto the display. Only one channel. Multiple channels are coming, but only one channel is going to display, and that you are going to select. So the same function is done by the multiplexer. It has many input. Depending upon select, only one input is transferred over to the output. Is it okay? So that is why it is also called as data selector. And multiplexer, a universal logic circuit. Any circuit which can implement all the basic gate functions can act as a universal logic circuit. Is it okay? So multiplexer is also a universal logic circuit. Let's try to understand the multiplexer. So suppose if we have basic representation of the multiplexer, please observe beta ji. Suppose if we have this symbolic representation, so it has two select input. Based upon the select, one of the input is transferred to the output. Okay, also called as many to one circuit, because it has many input lines. Only one of the input line is transferred to output. Only one of the input line is transferred to output depending upon select. Depending upon select. Is it okay? So this is a standard representation of a multiplexer. If we talk about size of the multiplexer, then size of the multiplexer is always defined as m cross n, where m is the number of inputs and n is the number of the outputs. So you can also say, sir, can I say like this, m cross n, 1? Yes, because multiplexer will have only one output. Multiple input, one output. Can I also like represent it as 2 to the power n cross 1? Yes, you can represent like this, where n is the number of select line. So if we have two select line, how many number of input lines are there? 2 to the power 2, that is 4. So there is a relation between input lines and select lines. Is it okay? Yes, sir. So just I am making a note here. Please observe here. The size of mux. Size of mux is defined as, in short, multiplexer is called as mux. So size of mux is defined as 2 to the power n cross 1, where n is representing number of select lines. Is it okay? Also you can say m cross 1. So m is number of inputs. So if we know about number of select line, we know about number of input line. If we have a number of input lines, we can have a selection of number of selection line, or also called as control line or select line simply. Is it okay? Let's try to understand functioning of the multiplexer. Later on we will design the multiplexer. Is it okay? Yes, sir. So please observe. Let's try to understand the basic multiplexer. I am considering the smallest size of the multiplexer, that is 2 cross 1. So what does it mean, 2 cross 1? If we have 2 cross 1 multiplexer, it means it has two input lines, only one output line. And how many number of select line? 2 to the power 1. So that only one select line. Is it okay? Yes, sir. So now all of you able to understand the relation between number of inputs, number of select line, and size of the mux. To design any combinational circuit, first of all, we need to understand the inputs and outputs. Now we know about the inputs and outputs. In order to represent inputs and outputs, I am just representing the basic circuit of 2 cross 1 mux. So we have two inputs, one output, because 2 to the power 1 cross 1 will become the size of 2 cross 1. So that indicate there is only one select line. Is it okay? Now input lines are represented conventionally top to bottom, LSB to MSB. Is it okay? Conventionally. However, if the representation is given, you have to follow the given representation. Conventionally, always top to bottom, LSB to MSB. And we have output Y. Please observe beta ji, very interesting. In order to understand the circuit behavior, we must know about the switching circuit of multiplexer. So let's understand switching circuit of multiplexer. Please observe here. Switching circuit. Switching circuit can make you understand the relation between inputs and outputs. Now please observe here. We have a 2 input. Okay. Yes, sir. 2 input line. And we have, sir, 1 select line. Now all of you can understand this select line. You can assume this select line that this select line is connected with a spring. Okay. And there is a string. And there is a string connected with this switch. Whenever I say that this switch is logic level 1, it means I am just making a force onto this string. So definitely whatever information is connected here, I1 pin, that is going to be transferred to output Y1. In case if I am not applying any force on this string, you can say the spring will return this to the I0 position. So when it return to the I0 position, it will get connected with the I0 position when S0 is equals to 0. When I am not making any force, you can say I am not making any force. The switch is connected with Y0. If I am creating a force onto this string, then I1 is going to be connected with this switch. Is it okay? Yes, sir. So this switch, if the switch S0 is equals to 0, I0 information, whatever information is onto the input pin I0, that is going to be transferred to output Y. In case if S0 pin is equals to 1, then the switch is connecting output to I1 pin. So whatever information on I1 pin, that is going to be transferred to output Y. Now all of you able to understand the switching circuit. From the switching circuit, we can construct truth table. To design any combinational circuit, first of all, we need to identify the inputs and outputs, construct truth table, write logical expression and implement the logic circuit. So I am interested to design the logic circuit of a multiplexer. For that, first of all, I need to understand the input-output relation. So I have identified now about the inputs and outputs as well as the relation between the inputs and outputs, what we want to design. Is it okay? Yes, sir. Now based on that, we can construct truth table. Please observe, Bitaji. So in truth table, we have first select, then we have a input I0, I1 and the output Y. So we have select I0, I1 and the output Y. How many of you able to understand? Please observe. Let me know by writing in the comment section, Bitaji. So sir, we have a select S0, input we have I0, I1, or can I write like this? We have a I1, I0 and we have a select. Based upon the select condition, the information given to I0 or I1 is transferred to output Y. Is it okay? Yes, sir. So what are the possibilities in terms of logic levels to the input I1, I0 and what are the possibilities of S0? We all can see either I0, I0, either all are low, any one of them is high. Please observe very carefully, Bitaji. Or any one of them is high or any two of them are high. Is it okay? Now we have a 3 input conditions. 2 are the input pins, 1 is the select. Yes, sir. Or we have I1 high, both low, or we have any 2 of them are high or all are high. So total we have 8 possibilities which can be represented in terms of binary as binary of 0, binary of 1, binary of 2, binary of 3, 4, 5 and 6. But with the consideration I0 as a MSB, I1 as a MSB and S0 as a LSB. So if I consider I0 as a MSB and S0 as a LSB, then the conditions can be represented in terms of the binaries from 0 to 7. Is it okay? Now output Y. As we have observed the switching circuit, output Y will become logic same as either connected to I0 or I1 depending upon the select condition. So in case if the select condition S0 is 0, in case if the select condition S0 is 0, it means this switch is connected with I0 pin. So whatever information is onto the I0 pin, that is transferred to output Y. In the same way, one can say, sir, when S0 is 1, it means whatever information on I1 pin, that is going to be transferred to output Y. In the same way, for 0, I0 information is transferred to output Y. For 1, I1 information is transferred to output Y. For 0, I0 information is transferred to output Y. For 1, I1 information is transferred to output Y. For 0, I0 information is transferred to output Y. For 1, I1 information is transferred to output Y. How many of you able to understand, beta ji? Great, sir. So it's very easy. Now please observe where we are getting output logic high, so that we can have a logical expression needed to design this particular circuit. We always do the same. Construct, first of all, we need to identify the inputs and outputs, and in order to understand their behavior, I have used switching circuit. Construct truth table. Next is to write logical expression. So write down the logical expression of output Y. What is the logical expression of output Y, beta ji? Can you please tell me what is the logical expression going to be for the output Y? Please observe. We are getting output logic high onto the binary conditions of. We are getting output logic high onto the binary conditions of, sir, 2. Then we have 5, 6 and 7. 2, 5, 6 and 7 in terms of I1 as a MSB and IS0 as a LSB. So we can have K map of 2 cross 3 size. Please observe very carefully, beta ji. There is one more approach to write the logical expression, but let's go with the conventional first. Now we have a I1 complement I0 complement I1 and I0 complement S0 complement I0 complement S0, I0 S0, I0 S0 complement. So we have a numbering 0, 1, 2, 3, 4, 5, 6 and 7. Where we are getting output logic high, beta ji? 2, 5, 6 and 7. 2, 5, 6 and 7. 2, 5, 6 and 7. So definitely we have to go with the essential prime implicant first. In order to minimize the min term present at 5, we must need to take this pair. In the same way, in order to minimize min term at 2, we must have to take this pair. And after taking these two pairs, all other pairs are going to be redundant because already all the logic ones are covered. Is it okay? So what is the logical expression we are getting? For our output Y, we are getting for our output Y as I1 S0 plus of I0 S0 complement. Great, Sarji. Great, Sarji. How many of you able to understand, beta ji? Please let me know by writing in the comment section. Great, sir. Sir, can we go with this expression directly? Some alternative approach also we can opt. Yes, we have a tabulation method. If we opt a tabulation method, then also we can find the logical expression. Let's try to opt a tabulation method as well. So let's go with the alternative approach. In an alternative approach, we can construct a truth table. And in this truth table, actually, we are observing that output is one of the input. Because of the select line, output is one of the input only. So how many possibility of the select line? There are two possibility, either 0 or 1. If S0 is 0, we are getting I0 as the output Y. And if S1 is 1, we are getting I1 at the output Y. So by observing this alternative approach of the table, you can say, sir, Y is equals to I0 we are getting when S0 complement is high. If S0 is low, it means its complement is high. Otherwise, we are getting I1 when S0 is high. So we can represent the output logical expression in this way as well, directly by using this alternative approach, which you have observed in most of the books as well. Is it okay? Great, sir. Now, next is your circuit implementation. So, to implement or to design any logical combinational circuit, first we need to identify the inputs and outputs, write the truth table, then find logical expression, minimize it, and then implement the logic circuit. So what logic circuit you are able to see? Sir, we can see there are two AND gates. One AND gate will give you I0 S0 bar and one will give you I0 S1. And we need one OR gate. Is it okay? Yes, sir. We have one pin as I0 pin and we have one pin as I1 pin. And we have S0 and S0 complement. Select 0 and select 0 complement. How many of you can now understand the circuit of a 2x1 mux? Very important circuit. Maximum it is used in banking systems. In your ATMs, these multiplexers have a lot of, actually they are used in digital lockers basically. Okay, so there is a lot of uses of the multiplexer. How many of you able to understand up to this part, Betaji? If we have select here, we are getting S0 complement here. We are getting I0 S0 complement. We will get I0 only when S0 is low. Otherwise, if S0 is high, this AND gate get disabled. If we get this S0 bar 0, this AND gate will get disabled irrespective of I0. Now no information is going to be transferred. If S0 is equals to 1, then this AND gate get enabled. So select line is going to enable one of the AND gate in the circuit. Basically, select lines are going to enable or disable depending upon which input need to be selected at the output. Accordingly, it is going to enable that particular AND gate. Is it okay? Great, sir. How many of you able to understand up to this part? Please let me know by writing the comment section. Suppose if we have a select as a input A, then what we will get here? Here we will get A, and let us suppose we have B and C. So what we will get at the output? A bar B. Here we will get A bar C, and at the output we will get A bar B plus A bar AC bar. Sorry, this is A bar AC. AC. So we will get A bar B plus AC. How many of you able to understand this part perfectly? Please let me know by writing in the comment section. So can you now onward, whenever this circuit is going to show, you can analyze the internal circuit. Yes, sir. Two AND gate, one OR gate, and a NOT gate with the select line. How many of you can now understand what is inside this square box calling as a multiplexer? Great, sir. Let's try to understand with one more size, that is 4x1 size. Okay, let's try to understand with one more size, 4x1 size of multiplexer. Please, I need a response from everyone in the comment section, Betaji, because that is basically the source of my energy. Okay, so let's go with the 4x1 size multiplexer. What we want to design? We want to design a 4x1 size multiplexer where the number of inputs are 4 and number of inputs are 4, it means m is equals to 4. So if m is equals to 4, m cross 1, where m is 2 to the power n cross 1, and I am talking about 4 cross 1. So what does it mean? 4 cross 1 means how many number of select lines are there? 2 select lines are there. So how many number of select lines are there? 2 select lines are there. So we have 2 to the power 2 cross 1 size mux, or you can say 4 cross 1 size mux. How many of you able to understand? Great, sir. Now please observe, in multiplexer we have multiple input, m number of inputs, m is equals to 2 to the power n, where n is number of select lines and only one output line. Multiplexer is also called as data selector because depending upon the select line condition, one of the input is transferred to output. One of the input is transferred to output. Now I am hoping all of you able to understand. Sir, in case if we have 0, 0, so which input is going to be transferred to output? Sir, for 0, 0, I0 need to be transferred to output Y. For 0, 1, I1 need to be transferred to output Y. For 1, 0, I2 need to be transferred to output Y. If you are going to apply binary of 3, 1, 1 onto the select line, sir, I3, whatever information given to I3 pin, that is going to be transferred to output Y. Is it okay? Yes, Beta ji. What is the difference? Sir, will you cover the whole syllabus? Should I join gate wala? Yes, Beta ji. What is the difference between the paid? Already I told you, I am a teacher. I can't select like on YouTube I am going to give a little bit, and on a paid course I am going to give everything. I can't do that. It's just against my ethics. I can't do that. Okay, so I am going to cover everything here as well. But definitely there is some time constraint, so I will move very faster. Number of questions may be discussed lesser, as well as to complete it within the possible timeline, because we have to discuss all subjects onto the same your Gatewala English channel. So it will be very difficult. Okay, so there is some time boundation, and definitely I have to move little bit faster, and some of the portions may I'm not able to discuss here. Maybe. Is it okay? But if you are sincere enough, if you have any kind of financial issue that you can't join, then you can watch and you can have a maximum benefit from this series as well. Is it okay? Great. And it's my promise to you, even if you are going to learn a digital from here in a very rapid manner as well, going with your PYQs, you are going to cover 100% marks from digital. Is it okay? Unless some very extraordinary things are going on, where many practice is required. Otherwise, you can easily get 100% numbers in your digital. Okay. 80%. Anyhow, you are getting 80% and 100% if you are just practicing some of the PYQs. Now come back to this 4 cross 1 size mux. Okay. Now please observe here. How a 4 cross 1 size mux? Great, beta ji. How a 4 cross 1 size mux will work? All of you able to understand, if we are going to apply 0, 0, then definitely I0 information is going to transfer to output Y. For 0, 1, I1 pin information is going to transfer to output Y. For 1, 0, I2. For 1, 1, I3 pin information is going to transfer to output Y. Now please observe. To design any combinational circuit, we must have to write truth table first. Now we can go with the tabulation basic. Yes, sir. So we have a inputs are transferred to one of the output depending upon the select line. So based on the select line, how many possibility? Sir, we have total 4 possibility. Either both are 0, 0, any one of them is high, or both are high. What happens for 0, 0? For 0, 0, I0 pin information need to be transferred to output Y. For 0, 1, I1 information need to be transferred to output Y. For 1, 0, I2, and for 1, 1, I3. Whatever information we are going to put on I3 pin, that is going to be transferred to output Y. From the table, we can construct logical expression. So if you observe a logical expression output Y, we are getting I0 when S1 is low as well as S0 is low. Else we are getting I1 when the binary of one condition will appear onto the select line. Otherwise, we may get I2 if the binary to the select is a binary of 2, that is S1, S0 complement. It means S1 is high, S0 is low. Otherwise, S1, S0. So in multiplexer, one of the input is transferred to output depending upon select line. Only one of the input is going to transfer to output. Why? Depending upon select line. How many of you able to understand, beta ji? So now we have logical expression for the output Y as well. So to design any combinational circuit, we need to identify the input outputs, construct truth table, write logical expression, and then implement it. So if I want to implement, then we need 4 AND gate for a 4 possibilities. We need 4 AND gate. Is it okay? Yes, sir. Now the output of each AND gate is passing through the OR gate. The output of each AND gate is passing through the OR gate. How many of you able to understand, beta ji? Just let me know. And sir, we have I0 pin, I1 pin, I2 pin, and I3 pin. One of the input pin is transferred because I am the designer. So I must need to define the input pins because only I know which pin and how we are going to connect. So if we talk about conventional representation, that is always top to bottom input pin LSB to MSB. But in an actual cases, wherever they are indicating the input pins, we have to go accordingly. Is it okay? Because only designer knows which one is a MSB pin and which one is a LSB pin. Okay? Yes, sir. Now please observe here. In this, we are designer. So we are designing as per the conventional information or representation. Okay. So here we have S0 and S1. Always remember the select lines are always defined. The select line Arey beta, all faculties are top-notch faculties. Only you need to have patience because every subject is a little bit different. Is it okay? So please keep this in mind. And remember, if you keep patience now, no, it is not possible that you will not able to understand. Is it okay? Now please observe. We have I0, I1. So I am just representing here I0. Okay, and we have I0, I1 complement, I1, I0 complement, I1. Then we have I1, I0 complement, I1, I0. Now please observe, whenever these dark symbols are represented, it means the two lines are shorted. Okay. Other things, these are all overlapping. So always remember this. These dark dots are representing a connection. These dark dots are representing connections. Is it okay? Otherwise, they all are going overlapped. Okay? Yes, sir. So how many of you able to understand this 4x1 size mux? Great, sir. We have a 4x1 size multiplexer. So all of you now able to see the internal circuitry of a 4x1 size multiplexer. Beta ji, please let me know by writing in the comment section. I need your response. I0, I1, I2, I3, and we have output Y. Suppose if the information given here is A and the information given here is B, then we all can see this will become A bar, B bar, A bar, B, AB bar, and AB. And they are going to multiply with the inputs because this is going to enable this AND gate or disable depending upon A and B condition. And suppose if we have here, C, D, E, F. So depending upon the A bar B condition, one of the output line is going to be high. How many of you able to understand this output perfectly? So we have A bar B bar C plus of A bar B D plus of A B bar E plus of A B F. How many of you able to understand this 4 cross 1 size multiplexer? 4 cross 1 size multiplexer. Beta ji, I need your response. Please let me know by writing the comment section. Great. Thank you, Beta ji. So please let me know. See, Beta ji, electrical is the mother branch. So most of the subject except your communication. I can't teach communication. Okay. I can't teach EDC. However, I know EDC, but I can't teach EDC up to the level that those other can teach. Your specialist teachers can teach. Okay. So for electronics student, also there, whosoever is going to teach you na in this batch, you are going to love that particular subject. It's my challenge. Like I'm saying that anyone, if coming in this channel na, on the subjects, they are the most you are going to fall in the subject's love. Okay, it's my bet. It doesn't matter whosoever come, we all are a single team. Okay, great. So now let's have a discussion towards logic circuit of 4 cross 1 mux. We have a logic circuit of 4 cross 1 mux as well. Can you design a 8 cross 1 mux? Come back to the subject again. Please tell me, can you design 8 cross 1 mux? Yes, sir. How many number of AND gates are there? 8. 8 AND gate, 1 OR gate, and we all know about the inputs to the AND gates, because in 8 cross 1 mux there are 3 inputs. So for 3 inputs we have total 8 combination possible, and from I0 to I7 it is going to select one of the pin. How many of you can visualize the internal circuitry of 8 cross 1? How many of you able to visualize the internal circuitry of 8 cross 1? Yes, sir. We are able to visualize the internal circuitry of 8 cross 1 as well. Sir, we are able to understand the internal circuitry of 8 cross 1 as well. In a 8 cross 1, we have I0, I1, I2, I3, I4, I5, I6 and I7. Okay. Yes, sir. So if we talk about 8 cross 1 mux, then S0, S1 and S2. Depending upon the select line, one of the input is transferred to output Y. So all of you can visualize there is one AND gate here, one AND gate here, and so on. So what we are getting at the input of the AND gate, let us suppose onto the select line the inputs are A, B, C. So we will get, sir, A bar, B bar, C bar. We will get A bar, B bar, C. It means binary of 0, binary of 1, then I1 gets selected. A bar, B, C bar. Because of the select line, we can observe the AND operation we are getting just similar to the 4 cross 1. We have this A bar B. In the same way, now we have 3 select lines A, B, C. So we have A bar, B bar, C bar, and input I0. A bar, B, C multiplied with input I1. A bar, B, C bar multiplied with input I2. In the same way, A bar, B, C multiplied with input I3. A, B bar, C bar. A, B bar, C. A, B, C bar, and A, B, C. So these are the conditions coming because of the select line. Whatever information at I0 pin, that is going to be multiplied. In the same way, A bar, B bar, C is the condition which enables the AND gate with the input I1, and whatever input at I1, that is going to be multiplied. Entire is going to be passed through the OR gate. Is it okay? Yes, sir. So we all can see the internal circuitry. Great, sir. For a moment, suppose I am interested to observe what is the logical expression from this given 8 cross 1 multiplexer. So I am creating it like a question. Please observe. Suppose if I am interested to have the output logical expression obtained from this 8 cross 1 size mux. 8 cross 1 size mux. So can you find out the output expression from 8 cross 1 size mux? Yes, sir. Because of the select lines, by default, we all know that right to left we have LSB to MSB. Is it okay? Onto the select line. So based upon the select line, we have a select line condition as A bar, B bar, C bar for I0 and so on. Now this is going to be multiplied with this. So what we will get? 0 plus this will be multiplied this. We will get 0 because 0 multiplied by anything is 0. This will be multiplied with 1. So we will get A bar, B, C bar plus this will be multiplied with 0. I3 pin. So we will get 0. On I4 pin, we have 1. So A, B bar, C plus I5 pin, we are getting 1. A, B bar, C. A, B bar, C bar for I4 pin and A, B bar, C for I5 pin. Rest 0, 0. So we'll get 0 plus 0. So the logical expression obtained from the given multiplexer is A bar, B, C bar plus of A, B bar, C bar plus of A, B bar, C. Now there is a possibility that multiplexer may give an intermediate expression. There is a possibility that multiplexer may give an intermediate expression. However, what we are observing here, each product term contains all variables. So it's a canonical. So in a canonical, you can say, sir, we have summation of m. What are the positions, beta ji? You can observe here, this is the binary of 4, 5 and 2, 4, 5. 2, 4, 5. It will be quite easy to identify the outputs in case if all the variables are onto the select line. Because if all the variables are onto the select line, just you can have observation what are the input lines where we are getting logic 1. So that is your output function of the multiplexer. How many of you able to understand the 8 cross 1 multiplexer as well, internal circuitry of the 8 cross 1 multiplexer and the process to solve multiplexer questions? Haji beta. Beta, I don't know all in one. Beta, I can't say whether it will come or not because it totally depends upon our availability. Okay. But the common subjects are definitely going to come. But I can't say about the specialized subject whether we are going to cover this year or not. I can't commit right now. Maybe it will come. Please follow our Telegram. We will give all the updates and it totally depends upon the demands of the student. Basically, if on YouTube we are getting demands, we are getting like number of students are interested, we will go in that way. There is no issue. Okay. Now, how many of you able to understand up to this part, beta ji? Please let me know by writing in the comment section. Okay, so can you design a 16 cross 1? Yes, we can design 16 cross 1. Can you design a 32 cross 1 multiplexer? Yes, sir, I can see 32 cross 1 multiplexer internal circuitry as well. 32 AND gates are there. 5 select lines are there. We know we can design 128 cross 1, 256 cross 1, 512, 512 cross 1, 1024 cross 1. So yes, sir, we can design now any size. But sir, we all know that number of inputs to the AND gates will have some certain amount fixed depending upon the design of the AND gate with the logic family and fan in or fan out. So if we are thinking that we can design any size in the same manner, it will not go like that. We have to go with the different logics. So can we design a higher size multiplexer by using lower size multiplexer? Suppose I'm interested to design a 4 cross 1 multiplexer, but in the market only 2 cross 1 size multiplexer is available. So can I design a 4 cross 1 by using 2 cross 1? Is it okay? Let's talk about in that way. So can we design a higher order multiplexer by using lower order multiplexer? Yes, sir, we can design a higher order multiplexer by using lower order multiplexer. So please write down a heading. higher order multiplexer by using lower order multiplexer. Higher order multiplexer by using lower order multiplexer. Higher order mux by using lower order mux. So suppose I want to implement a 4x1 size multiplexer, but there is a restriction. I can't design a new multiplexer and availability is of 2x1 multiplexer. So how can I design? Please observe, beta ji. We want to implement 4x1 size multiplexer and the availability with us is 2x1 size mux. Is it okay? So first of all, observe the highest number. The highest number here is 2 and the highest number here is 4. Definitely in case of multiplexer, you will get the highest number onto the left side. Is it okay? Yes, sir. On the size described, always you will get onto the left side. Is it okay? Yes, sir. Now start dividing this higher number with this with which you want to implement. So with how many times you can divide this 4? Sir, 2 times. And now again divide this 2 with this. So how many times you can divide? Sir, 1 time. So total number of 2x1 multiplexer needed will be, 3. And the most important thing is this division rule also shows you the construction, how you can implement. Now please observe, 2 means I am representing 2. Can you please tell me in the comment section how many number of select lines are needed in case of 4x1 size multiplexer? How many number of select lines are needed in case of 4x1 size multiplexer? We need 2. So here we have 2 cross 1, 2 cross 1. This 2 is indicating 2 cross 1, 2 cross 1. Is it okay? And this 1 is indicating ahead to this we have 2 cross 1. Is it okay? Yes, sir. Now please observe, in case of 4 cross 1, we have total 2 select lines. But here we have 3 multiplexers. Now please observe, the LSB select line is decided based upon your multiplication. First term that you are getting. So first division we are getting 2. So in these 2 we have same select line, that is S0. In these 2 we have same select line, that is S0. And then we did this. So we are getting next select line. In the same way it goes on. Now please observe, beta ji, whatever output is from the previous multiplexer is going to become the input to the next multiplexer. So this 2 plus 1 also indicate you how to connect 2x1 multiplexers to construct a 4x1 size multiplexer. Now please observe, conventionally this is your I0 pin, this is your I1 pin, I0 pin, I1 pin, I0 pin and I1 pin. And we have output Y. Is it okay? Yes, sir. Beta ji, please observe here. Suppose if we have A, B, C, D, then can you please tell me what is the select line conditions S1, S0 for output to be equals to C? What is the select line condition of I1, I0 for output Y is equals to C? Can you tell me? Please find out. Find the select condition for output Y equals to C. So I am creating a question as well. So can you find the select line condition S1, S0? Find select line condition, select S1, S0 condition for output Y is equals to C. So sir, definitely for output Y is equals to C, this select line in order to choose C must be 0. Why, sir? Because if this is 0, then this is going to select A and this is going to select C. Is it okay? And for C to be the output, this select line must be equals to 1, because then only the output, this is connected with the I1 pin. So C will come at the output. How many of you able to understand? Yes, sir. What is the binary condition for the availability of C? If we use a general 4x1 size mux, then it will start I0 pin, I2, I0 pin, I1 pin, I2 pin and I3 pin. So binary of 2. How many of you able to understand? How many of you able to understand? S1, S0, binary of 2. I0, I1, I2, I3. This is true for the conventional representation. How many of you now able to understand, Betaji? Great. Let's have one more implementation. Suppose if we want to implement 8 cross 1 size mux, but the available multiplexer is only of 2 cross 1 size. Available multiplexer is only of 2 cross 1 size. So how we can implement? Please observe, Betaji. So sir, we want to implement a 8 cross 1 by using 2 cross 1. So how many number of 2 cross 1 size multiplexers are needed? Let's divide, sir. So 8 by 2 we are getting 4. This 4 by 2 we are getting 2, and this 2 by 2 we are getting 1. So that is total is equals to 7. We need 7, and also we know about the implementing circuit. So 4 we need 4 2 cross 1 size mux here. 1, 2, 3, 4. Then we need 2 cross 1 size mux, and then we need 1 2 cross 1 size mux. How many of you able to understand? Please let me know by writing in the comment section, Betaji. Standard representation in general, if inside the multiplexer 0 and 1 is represented, then that is indicating I0, I1 inside the multiplexer. Outside the multiplexer box, if any logic level is representing, that is the true logic level applied at the input. Inside the multiplexer, the logic level indicating inside the box of the multiplexer is usually describing the input pins. So we have I0 pin, I1 pin, I0 pin, I1 pin, I0 pin, I1 pin, I0 pin, I1 pin. Instead of writing I0 and I1, sometimes it is directly represented as 0, 1. Is it okay? Inside the box, if 0, 1 is mentioned in the multiplexer, then it is always indicating I0, I1 pin. Is it okay? It is not indicating the logic level 0 and 1. Now please observe. So these four will have same select line. So because the division is started from here, so this is your select line S0, and it means least significant bit. Then the outputs of these will become inputs to the next upcoming 2 cross 1 size multiplexer. We have 2 cross 1, 2 cross 1, 2 cross 1, 2 cross 1. Now second we have 2, so this will be your S1, S1. In the same way, we have S2 pin, and this is also I0, I1, I0, I1, I0, I1, output Y. Now if I ask you, can you please tell me what should be the decimal equivalent of the select line condition? What should be the decimal equivalent of the select line condition for output Y equals to F? Can you please tell me? Can you please tell me what will be the select line condition for the given 8 cross 1 multiplexer, which is implemented by using 2 cross 1 size multiplexer? Decimal equivalent of the select line condition. So sir, we will get output F is equals to 1. Y is equals to F. When? Since this is a standard representation, top to bottom, LSB to MSB, standard representation. So in this case, we have to observe I0, I1, I2, I3, I4, I5, I6, I7. Is it okay? So F means I0, I1, I2, I3, I4, I5. So definitely we are getting the binary of 5. It means S2, S1, S0 must be equals to 1, 0, 1. That is, if we convert it into decimal, we have 5. How many of you able to understand, Betaji? Sir, can you please show us? Okay, let's try to observe as well. 1, 0, 1. So what is S0? S0 is 1, S0 is 1, S0 is 1, S0 is 1. So 1 means out of A and B, B has been selected by this multiplexer. Out of C and D, D is selected. Out of E or F, F is selected. Out of G or H, H is selected. Now this is 0. 0 means out of 0, 1 select lines, B is being selected. Out of this, F is selected. Again, S2 is logic level 1. So F is being selected at the output. How many of you now able to understand, beta ji, working of a multiplexer, even implementation of higher order multiplexer by using lower order multiplexer? No, 7. It's beta, it will be started from here. I0, I1, I2, I3, I4, I5. 5. It's a binary of 5. If you started from here, the representation is different. Always observe the representation. Conventional, it is top to bottom. If it is mentioned in a different way, then that will be considered. Is it okay? Let me show you once again. Let me show you once again. Please observe. Can you please tell me how many number of 16 cross 1, how many number of 4 cross 1 size multiplexer is needed in order to implement 16 cross 1 multiplexer? Sir, we want to implement 16 cross 1 and the available size is 4 cross 1. We know about the implementation, sir. This is going to be 4 times plus 1 time. So total we need 5. And we also know how it is going to be constructed. So 4 means we need 4, 1, 2, 3, 4. 4 cross 1, then we need 1 4 cross 1. 4 cross 1 means 4 input line, 1 output line. 4 input line, 1 output line. 4 input line, 1 output line. 4 input line and 1 output line. Is it okay, beta ji? Yes, sir. Now please observe here. We have 4 cross 1, 4 cross 1, 4 cross 1, 4 cross 1, 4 cross 1. Now, first of all, we have to mark the representation of the pins. Okay, so we have I0, I1, I2, I3 pin. For these 4, we have 2 select line. Inside the multiplexer, select lines are always indicated as LSB, MSB. Is it okay? Inside the multiplexer. It started for these 4, we have S0 and S1. But inside the multiplexer, MSB, LSB, MSB, LSB, MSB, right to left, LSB to MSB. So S0, S1, S0, S1, S0, S1. This is the standard representation. Now we have 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. How many of you now able to understand? Please let me know by writing in the comment section. In the same way, for these we have 0, 1, 2, 3. It means depending upon the select line of S2, S3 condition, one of the input line of this multiplexer is being selected. Can you please tell me what should be the condition? Can you please tell me what should be the condition of S3, S2, S1, S0? Okay, what is the condition of this for output Y is equals to, suppose if we have A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So can you please tell me what is the decimal equivalent of the select line condition S3, S2, S1, S0 for Y output is equals to K? You are going to use this multiplexer. You are the designer, you are the user. So if you want to use this, you should know what input we will give, then we will get the desired output of the multiplexer. Is it okay? So, sir, it will be started from top to bottom. It's a representation, conventional representation, top to bottom. So I0, I1, I2, I3, I4, I5, I6, I7, I8, I9, I10, I11, 12, 13, 14, 15. So what do you want? K. K is I0, I1, I2, I3, I4, I5, I6, I7, I8, I9, I10. So what is the S3, S2? S3, S2, S1, S0 must be equals to 1 0 1 0. How many of you able to understand? Let's observe. Will it perform or not? So what is S3 S2 1 0, and what is S1 S0 1 0? 1 0 1 0 1 0 1 0. So can you please observe 1 0 is the binary of 2. So out of this, which pin is selected? C. For this multiplexer, it will pass G. For this multiplexer, it will pass K. For this multiplexer, it will pass O. Again, it is the binary of 2. So K is being transferred to output Y. How many of you able to understand the standard representation as well as implementation of a higher order multiplexer by using lower order multiplexer? Beta ji, can you please tell me 10, not 11. It always started from 0. I0 pin, I1, I2, I3, I4, I5, I6, I7, I8, I9, I10. Is it okay? Always started from I0 pin. Because 0, 0, 0 is also a condition. Under that condition of the select line, I0 pin is being selected. How many of you able to understand? Please let me know by writing in the comment section, beta ji. So can you design a 4 cross 1, 32 cross 1? Yes, sir. Now we can design any desired size. How many number of 8 cross 1s are required? How many of you able to understand this perfectly? Great, sir. Let's have a note point here. Please observe, beta ji. We have observed 2 to the power n cross 1 size multiplexer by using 2 cross 1 size multiplexer. Then how many 2 cross 1 size multiplexers are required? Let's start with this so you can answer easily. So how many multiplexers are required for this? How many multiplexers are required for this? How many multiplexers are required for this? So can you tell me how many multiplexers are required for this? Haji beta. Sir, it can be clearly observed we need 2 plus 1, that is 3. We also know about the implementation. 4 plus 2 plus 1, 7. For 16 we have 8 plus 4 plus 2 plus 1. Yes, sir. 15. So this will become 2 to the power n whole minus 1. Suppose if you want to implement 1024 cross 1 by using 2 cross 1. So how many 2 cross 1s are needed? 1023. Hoping all of you able to understand this. Great, sir. 2 to the power beta. 2 to the power n whole minus 1. 2 to the power n whole minus 1. How many of you now able to understand up to this part, beta ji? Please let me know by writing in the comment section. Don't write n minus 1. 2 to the power n whole minus 1. Okay, great. Please observe here. Find the output of mux. Find the minimized expression for output y from the combinational circuit shown below. So please observe beta ji, suppose if we have this circuit, that is your 4 cross 1 size mux. All of you are aware with the internal circuitry of the mux? Yes, sir. And we have S0, S1 and inputs are 1, 2, 3, 4, but indicated like this 0, 1, 2, 3. Inputs are indicated like this, and this is your grounded logic level 1, this is B, and this is your logic level 1. We have A, C. Can you tell me what is the logical expression for the output Y, minimized logical expression for the output Y shown in the figure? Haji. Now, please observe, most of the students start doing in the same way that we have A, C. So they just write here A bar, C bar, A bar, C, A, C bar and AC. But no, you have to observe the input pins, because we are not now designer. Designer only knows how the input pins are connected with the select lines. So we always observe, in case if the representation is not given, we can go with the standard top to bottom LSB to MSB. But in case if this representation of the input pins are mentioned, always follow the given representation. Always follow the given representation. So if you observe here, the representation is S0 is a LSB. We all know S0 and S1. So S0 is a LSB and S1 is a MSB pin. Is it okay? Yes, sir. And if we observe here, this is the LSB pin I0, I1, I2, I3. So as per the designer wants to suggest you that input pin select line, if A and C both are 0, 0, then I0 pin is going to be selected. So because of the select line action, we are getting A bar, C bar information at this particular AND gate. And one information is input. Now this is going to be multiplied by this. In the same way, we have I1, so A bar C, AC bar and AC. This is because of the select line. The given representation is not a standard representation. In case if the given representation is not the standard representation, always follow the given representation. If the representation is not given or a standard one, then it is very easy, because top to bottom LSB to MSB. Is it okay? Yes, sir. Now please observe, I need your response. So this is going to be multiplied with this, this is going to be multiplied with this, this is going to be multiplied with this, and entire is going to be passed through the OR gate. So what we will get? 0, because this ground means 0. This is a symbol of ground. Symbol of ground is indicating logic level 0. 0 multiplied by AC is 0 only. 1 multiplied by AC bar is AC bar. Here we have A bar BC. Is it okay? Yes, sir. We need not to worry about whether it is a bar CB or A bar BC. Is it okay? Unless MSBs and LSBs are defined in terms of the variables. If they are not defined, then we will treat A, B, C continuous series, A as a MSB and C as a LSB. Further, we have, sir, A bar, C bar. How many of you able to understand? Now, this is neither a minimal nor a canonical expression. Multiplexer may gives an intermediate expression. In order to understand what actual function implemented by the multiplexer, we need to write a canonical expression, and to find minimal, we can go with the K-map. So it is best to go with the K-map, because K-map shows all the possible minimal and all the possible canonical or an intermediate expression. Is it okay? So we have two variables. So design a K-map for two variables for the minimization or identifying the canonical expression as well. Please observe, beta ji. So we have A, B, C. I can observe three variables, A, B, C. So A as a MSB, then A bar A, B bar C bar, B bar C, B C, B C bar. Numbering 0, 1, 2, 3, 4, 5, 6 and 7. Where we are getting output logic high, beta ji? We are getting output logic high onto the A, C bar. How you will get A, C bar? A from here, and you will get C bar from 4 and 6. So it means A, C bar is a pair obtained from 4 and 6 min terms to be high. In the same way, A bar BC, you will get A bar here and BC you will get here. So this is 3. And A bar C, A bar you will get here, C bar you will get 0 and 2. So now you can observe the canonical as well as minimal. So what is the canonical expression, beta ji? We all can see it is high onto the binary of 0, 2, 3, 4, 6. Also we can observe the intermediate, all possible other intermediate expression or a minimal expression. So for a minimal, because it is minimized expression, we need to identify. We have a chord, and from this chord we get C bar, and then we have a pair. So what is the minimized expression we are getting? We are getting C bar plus of A bar B. C bar plus of A bar B. So this is the minimized output logical expression that we are getting from this output of the multiplexer. How many of you now able to understand the multiplexer and to how to solve the questions from the multiplexer? Can you please tell me, beta ji? Can you please tell me, beta ji? Great. So now we know how to represent any function from the multiplexer. Multiplexer is a universal logic circuit. What does it mean? It means any function can be implemented by using multiplexer. It means all the logic gates can be implemented by using multiplexer. Yes, sir. Let's try to identify how to implement logic gates. This will also give us information about selection of correct size of the multiplexer, which is most important. We can choose any of the size, but which size if we choose, then that is going to be the best size to implement our function. Okay. Now please observe, beta ji. First of all, I am interested to implement the logic function by using 2 cross 1 size mux. Okay. Let us first discuss about buffer. We all know about buffer. Buffer means the output is same as the input. Now please observe. The first thing is we try, whenever we have to implement a function from multiplexer, we try to put maximum number of variables onto the select line. Since we have a restriction of using 2 cross 1 size multiplexer, so we can have at least one variable onto the select line for designing any logic gate operation. Is it okay? In order to implement any logic gate function. Now please observe. So I am just keeping the select line onto the variable A onto the select line. What we want output? We want output y is equals to A. Because of the select line action, we all know at I0 pin we get A bar and at I1 pin we get A. Because of the select line, we all know, the select line will operate here S0 complement S0. So if we are going to apply A, it will become A bar A. So if we apply 0 here and 1 here, then our function will get implemented. Always remember, if all the variables are onto the select line, then it is very easy to implement function by using multiplexer. Why? Please observe, beta ji. We have only one select line, S1 or S0 is equals to A. So A may be 0, may be 1, and we want output to be 0 and 1. So what we need to do, we need to just copy this from here and paste it onto the select line. How many of you able to understand? In case if all the variables are onto the select line, just copy the output of the truth table to the input of the select line. Is it okay? Keeping one thing in mind, that top to bottom LSB to MSB for a standard representation. Otherwise, we have to focus to the representation as well. Easy? Yes, sir. Let's talk about NOT gate as well. Can you implement a NOT gate by using 2 cross 1 size multiplexer? So how many 2 cross 1 size multiplexers are needed to implement a function by using NOT gate? Sir, how many 2 cross 1 size multiplexers are needed to implement a NOT gate function? We want NOT gate function. We all know about the truth table of the NOT gate. In a truth table of the NOT gate, we all know we have an input A and the output Y. 0 we get 1 and 1 we get 0. Just copy your this part and paste here 1 0. If you paste 1 0, because of the select line action, we all can see that A bar is available here, which is going to be multiplied with this plus A is going to be multiplied with this 0. So we are getting y is equals to A bar. Not operation can be performed by using 2 cross 1 size multiplexer. Is it okay? Whenever we can put all the variables onto the select line, it will become very easy. You can just copy this and paste it here. So that is why the multiplexer is so choosable. It is very easy to implement any function. Is it okay? Yes, sir. Already we all can see that multiplexer in any of the circuit, if you observe, in any of the circuit, if you observe here, like for 2 variables, we have 4 possibilities. So all the 4 possibilities are here. Is it okay? Yes, sir. So basically, whatever you want at the output, you can just put at the input. That's all. Great. But that is only when all the variables are present onto the select line. Now, can you implement a AND gate by using multiplexer? How to implement a AND gate by using multiplexer? We want to implement AND gate operation by using a multiplexer. If we want to implement a AND gate operation by using multiplexer, okay? Yes, sir. So what we want at the output y? We want at the output y a dot b. Okay, so out of a and b, we can put one variable onto the select line. So I am using a onto the select line. Because of the select line action, we all can see onto the I0 pin we get a bar, and onto the I1 pin we get a, because we know about the internal circuitry of the multiplexer. If you forget about, if you are unable to recall, please observe what is inside the circuit of the multiplexer. Basically, this is inside the circuit of the multiplexer. In the box, whenever I see the box, this is the circuit that I can see. Basically, this is the circuit that I can see. So whatever we are going to apply onto the select line, we are getting a bar a. How many of you able to understand, Betaji? We are getting a bar a. Now onto the select line, what we have a input on I0 and I1 pin. So based on that, we have output y. What do you want? We want output y to be equals to a dot b. So a I have put onto the select line. Because of the select line function, this AND gate will have an input a bar, and this AND gate will have an input a. Is it okay? Yes, sir. Now, if we apply b here and 0 here, we will get ab. If we apply 0 here and b here, we will get ab. How many of you able to understand? So whenever I see this box, I am able to see inside the circuit of the box. How many of you now able to see this? Great. Let's have a discussion for the OR gate. So how we can implement a OR gate by using 2 cross 1 size mux? So how we can implement OR gate by using 2 cross 1 size mux? Sir, we want y to be equals to a plus b, but that is not possible with the help of a multiplexer directly. Why? Because multiplexer always gives AND OR circuit. It always gives AND OR circuit. SOP. Multiplexer always gives SOP output. This is a POS. How to implement a POS, sir? Can I represent like this? A plus b dot 1. Does anything get changed? No, sir, nothing. Can I represent like this? A plus b dot a plus a bar. Yes, sir, there is no issue. You can represent a plus a bar. By using distribution, by using transposition theorem, can I write a plus a bar b? Multiply same variables plus multiply different variables. Yes, sir. Now this is a SOP. Can we implement a plus a bar b? Yes, sir. A bar we are getting because of the select line action here, and a we are getting because of the select line function. Now if I apply logic 1, we will get a, and if I apply b, we will get a bar b. All are being passed through the OR gate. So we are getting a plus b, a plus a bar b. A plus a bar b, if implemented, it is an intermediate expression. Ultimately, it is implementing a plus b only. So how many number of 2 cross 1 size multiplexers are required to implement a OR gate? Only we need one 2 cross 1 size multiplexer. How many of you able to understand, Betaji? Great, sir. Now please observe. Can you implement a NAND gate, beta? Can you implement a NAND gate? A NAND gate will have a output y is equals to a dot b whole bar, which can be represented as a bar plus b bar. Is it okay? So if I put onto the select line a, Because of the select line action, we all know A bar is available and A is available. We have 2 cross 1 size mux. Since I want to implement A bar plus B bar, this is a POS. So to implement this, can I write like this? Yes, sir. So this will become A bar plus B bar. Can I write A plus A bar? Yes, sir. So A bar, if we multiply A bar plus of A B bar, can I implement like this? Yes, sir. Because of the select line action, we have A bar available here. So we can apply logic level 1. Because of the select line, we have A available here. So we can select B bar. But since we have to make a logic gate, so we don't have B bar. We need to create B bar. And for that, we need one more 2 cross 1 size mux. How many of you able to understand? Please let me know by writing in the comment section, beta ji. For B bar, we must have to pass like this. So if we want to implement a AND gate, we can implement by using 2 cross 1 size mux. What is the logic gate delay? What is the logic gate delay? One AND level delay, one OR level delay, 2 level delay. But if we want to implement NAND gate by using 2 cross 1 size, then what is the delay we have to suffer? One AND gate, one OR gate, then again one AND gate, one OR gate. 4 logic gate delay. So definitely this is not a recommendable size for an AND gate. However, 2 cross 1 is a recommendable size of AND gate operation, but it is not recommendable for NAND gate operation. Why? Because the delay is more. The most expensive thing is time and space as well. So we want our circuitry to be minimized. Is it okay? Nowadays come where everyone want that computer should be in the ring. The phone should be in the ring. If I want to see, I can just put the screen onto the wall. Okay. Now we don't want earphones. There are smart glasses where the bone travel earphones are there. Okay. So bone sensor earphones are there. Okay. So already these are already in the market. Anyone can buy. Is it okay? Yes, sir. So we want the things to be as compact as possible and as fast as possible. Here we can see the logic gates are also increasing. Almost 6 logic gates are needed. 2 AND gate, 1 OR gate, 2 AND gate, 1 OR gate. 6 logic gates are needed and 4 level of logic gate delays. So this is not recommendable for the NAND gate to design by using 2 cross 4 size mux. Is it okay? Yes, sir. Actually, I just wanted you to think what is the way how we are choosing the optimum size for the multiplexer. Is it okay? Yes, sir. Now please observe, can we implement a NOR gate by using 2 cross 1 size multiplexer? We have to implement a NOR gate by using 2 cross 1 size multiplexer. Please observe, beta ji, we want to implement A plus B whole bar, which can be implemented as A bar, B bar. So very easy. A bar is available because of the select line. A is available because of the select line action. So if you put B bar here and 0 here, we will get A bar, B bar. So in order to get B bar, we need one more 2 cross 1 size mux. That is I0, I1 pin and B here onto the select line 1, 0. How many of you able to understand? Again, for the NOR gate also we can see single 2 cross 1 multiplexer is not sufficient to implement NOR gate function. We need 2 cross 1 size multiplexer to implement NOR gate function because B bar is not available. Sir, mostly we say that variable and its complements are available. Yes, variable and complements are available whenever the data is coming from memory. Is it okay? But when we want to design a logic gate, we need B bar. When we want to design a logic gate, we need B bar. Is it okay? How many of you now able to understand, beta ji? Please let me know by writing in the comment section. Can you implement XOR gate as well? Let's talk about XOR gate. So we have 2 cross 1 size mux. I want to implement a XOR gate. XOR gate means Y is equals to A bar B plus A B bar. So if I put onto the select line A, because of the select line action, we have A bar and A available on I0 and I1 pin. On A bar we have to apply B, and on B bar we have A on B have to apply B bar. So how you will get B bar? B bar we will get, sir, if onto the select line we have B, then I0 pin, on I0 pin we get B bar, and on I1 pin we get B. So if we apply 1 0, we will get B bar as well from this 2x1 size mux. So we need two 2x1 size mux. How many of you able to understand, beta ji? Can you implement XNOR gate as well? How to implement XNOR gate? Sir, very easy. If we want to implement XNOR gate, A bar, B bar plus of AB onto the select line, if we have A, because of the select line action, we have A bar A, and we need to apply B bar B. Is it okay? Yes, sir. So how to get B bar, sir? How to get B bar, sir? In order to get B bar, in order to get B, we need to use buffer. And onto the buffer, I0, I1. So we are getting B bar and B, S not, so B. How many 2x1 size mux is required to implement XNOR gate? Again, we don't have B bar, na? We don't have B bar. I made a mistake. We don't have B bar. We want B bar. Okay, so this should be the correct one. 1 0. So you will get B bar because we don't have B bar. We need to use one inverter and one 2x1 size multiplexer. Is it okay? Now we have a XNOR gate. How many of you able to understand, beta ji? Please let me know by writing the comment section. Great. So now we all know about the internal circuitry of the multiplexer. We all know internal circuitry of the multiplexer. Also, we can see what is the size needed. Let's talk about the same logic gates. Can we implement the logic gates by using 4x1 size multiplexer? Yes, sir. Let's try to implement one logic gate by using 4x1 size multiplexer. And I am interested for a NAND gate. So can you implement a NAND gate by using 4x1 size mux? Yes, sir. 4x1 size means how many number of select lines are there? How many number of select lines are there? Sir, we have 2 select lines. For 4x1 we have 2 select lines. So select lines are S0 and S1. And we have 4 input lines. So we have 4 input lines I0, I1, I2, I3. This is a standard representation. Yes, sir. So based upon A and B, A is a MSB and B is a LSB. So I am connecting A onto the LSB pin S1 and B onto the LSB pin S0. Is it okay? Yes, sir. Now please observe. We want output function y is equals to A dot B whole complement, which can be indicated as A complement plus B complement. Is it okay? Yes, sir. For if we want to implement any function and the number of select lines and number of variables of a functions are equal, then it is very easy to implement a function by using multiplexer. Because in that case, just we have to see the truth table of the function we want to implement. For a NAND gate, we all know 0 0 0 1 1 0 1 1. So we all know about the truth table of the NAND gate. Truth table of NAND gate. What is truth table of NAND gate, beta ji? 1 1 1 0. It is only 0 when both are high. Otherwise, it is logic level 1. So we need to copy this and paste it onto the input pin. So if I paste, it will become 1 1 1 0. Automatically your function will get implemented. How many of you able to understand, beta ji? Please let me know by writing in the comment section. So if we have to design a NAND gate function, if we want to implement a NAND gate function, and we have to choose the size either 4 cross 1 or 2 cross 1, so definitely we must need to choose 4 cross 1. Why? Only 4 AND gate and 1 OR gate, only 2 level delay. 4 cross 1 will have only 2 level delay. 4 AND gate, 1 OR gate, so only 2 level delay. Total number of logic gates are only 5. However, if the same NAND gate is implemented by 2 cross 1, total number of logic gate increases to 6, and the logic delay will become 4 level of logic delay. So if we want to implement, this is also a 2 variable function, but if we want to implement a function and the complements are not available, then 4 cross 1 will be a better size comparative to 2 cross 1. Now, how many of you able to understand, Bitaji? Can you please tell me by writing in the comment section, Bitaji, how many of you able to understand this? Can you implement a XOR gate? Yes, sir. How to implement a XOR gate? Sir, very easy. We have S0, S1. So you can put AB here. You want A bar B plus A B bar. Very easy, sir. I0 pin, I1 pin, I2 pin, I3 pin. For XOR gate, we all know the truth table. So just paste the truth table onto the I0, I1, I2 and I3 pin. We all know because of the select line, we have A bar, B bar, A bar, B, AB bar and AB. So this will be multiplied with 0, 0. This will be multiplied with an A bar B. This will be multiplied with an A B bar. This will be multiplied with 0, 0. So it is very easy to implement function if all the variables are onto the select line. It is very easy to implement a function if all the variables are onto the select line. Is it okay? Please let me know by writing in the comment section, Bitaji. It is very easy to implement function if all the variables are onto the select line. How many of you able to understand up to this part? Please let me know by writing in the comment section. If all the variables can be placed onto the select line, then it is very easy to implement it by using a multiplexer. I am not getting any responses from anyone. Where are all of you? Haji beta, is it okay now? Great, sir. Can you tell me the answer for this? This question is asked in gate. It's a gate question only. Can you please try to solve this multiplexer output function f? Sir, in this case, the function f implemented by multiplexer is shown in the figure. Okay. And we have B, the output is now connected with the select line. Definitely this is a select line because 0, 1 is given here and we all know about what is 0 and 1. Here they have represented I0, I1 inside the multiplexer. Inside the multiplexer, they have mentioned this 1 cross 2 cross 1 mux. Inside the multiplexer, if logic level 0 or 1 is given, it means that is I0, I1. And here we have a C and C bar. So we all can see because of the select line action, the function available here is B bar and the function available here is B. B bar is multiplied with this C, so we will get C B bar plus of B C bar. So C XOR B or B XOR C. And that is coming to the select S naught. So this will become B XOR or C XOR B, C XOR B whole complement, and this will be C XOR B. Because C XOR B is a result, you can take it as X. So now what is your function f? Function f will become A dot, this is going to be multiplied with this, this is going to be multiplied with this, entire is passed through the OR gate. We all know about the internal circuitry. So A dot C XOR B whole complement, which can be represented as C XOR B. And what is C XOR B? A C bar B bar plus of CB. So we all have, Haji beta, We all have A dot C bar B bar plus of A C B. Is there any option related to this? This one, sir. How many of you able to understand? Good evening, Betaji. How many of you able to understand? Please let me know by writing in the comment section. See, forget about what they are going to ask. We have a syllabus and sufficient time as well. So our first objective is to focus to complete our syllabus. Instead of thinking that in 2025 they have asked from the matrices, in 2026 they have asked from the suppose the differential equations. So maybe this year they are going to ask something from the linear algebra and so on. Instead of going in this way, it would be better to presently what we can do is better to go with the entire syllabus. All these questions will come when only 2 or 3 months are left out. And you have to select what we can study and what we can leave. At that time, that question will arise. Presently, please focus onto the covering your syllabus as much as possible. Is it okay? Try to cover the syllabus in such a way that you will be able to answer any kind of different type of questions that can be designed from the particular topic. Is it okay? Like all of you are aware with the matrices. So what are the different questions in the matrices? Either they can find the, either they will design a question by finding the rank, size of the matrices. Is it okay? Or determinant of the matrices, adjoint of the matrices. In that kind of questions, they are going to multiply the matrices, size of the matrix. So you have to know what are the different approaches for the different sizes that we can do. What is null matrix, what is diagonal matrix. If we are able to understand all these special cases, it will be easy. Is it okay? So start thinking like that. Instead of presently thinking whether we have to use or not, whether we have to study that particular topic or not, your first focus is to cover the entire syllabus first. All that kind of question what is going to be this year, we'll discuss when 2 or 3 months are left. Can you answer this one? Okay, great. Can you answer this one? The minimized expression of the output function f obtained from the multiplexer shown below will be. Can you answer this one? Sir, this is a standard representation or some different? Sir, it is not a standard representation, because in a standard representation, top to bottom LSB to MSB. Here it is bottom to top LSB to MSB. So definitely it is not a standard one. So how to write f? First of all, observe this 0, it means I0 pin. Onto the I0 pin, we get 0, 0. So binary in terms of AB will come A bar, B bar as a minterm. Here because of the select line, we are getting A bar B. Here because of the select line A B bar. Here because of the select line A B. So this will be multiplied with C. So F we are getting A B C plus A B bar C bar plus A bar B plus 0. Multiplexer may gives an intermediate expression, and output expression may be in some other intermediate form or maybe in a minimal form. So best is to go with a K-map, because K-map shows all possible different minimal as well as canonical expressions. Okay, and all intermediate expressions can be identified from the K-map directly. So only we have to draw this figure. Then A bar A, B bar C bar, B bar C, B C, B C bar. All these things also comes in your mind only. You need not to write all these things. The numbering is also in your mind only. Is it okay? I am hoping all of you now able to visualize the numberings boxes and different things. Just you have to put A B C. So A B C means 7. A B bar C bar, A B bar C bar. A B bar C bar, you will get A from here, and B bar C bar this. That is the binary of 4. A bar you will get from here, and B you will get from here. So the minimized logical expression possible will be this, this and this alone. Is it okay? So you will get A B bar C bar plus of BC plus of A bar B. Is it okay? Great, sir. How many of you able to understand, Betaji? Please let me know by writing in the comment section. They may ask you minimize, they may ask you canonical. They may ask you minimize, they may ask you a canonical. How many of you able to understand up to this part? Is it okay? Great. Actually, we can implement any function by using multiplexer. Mostly, whenever we have to implement a function, we have variable and its complement available, because when the data is coming from memory, that is a bistable multivibrators, under that condition we have both variable as well as its complement. Is it okay? So in such cases, if we talk about the sizes, then best size is for the multiplexer is such that the number of select lines are total number of variables minus 1, theoretically. So let's try to implement any function by using multiplexer. Let's try to implement any function by using multiplexer. Okay, so there is a fixed approach to implement any function by using multiplexer. Let's try to understand. Please write down, beta ji. Boolean function implementation by using multiplexer. Please write down Boolean function implementation by using multiplexer. There are some set of rules which if you follow, it will be easy to find out the input pins. Okay. Now please observe how to identify what we need to apply on the input pin and onto the select line. Okay. First, write down represent the given function in SOP form, because basic structure of multiplexer is and or. If we observe the internal circuitry of the multiplexer, it is always in the form of and or circuit. It is always in the form of and or circuit. Multiplexer basic circuit is and or circuit. So it is always in the form of and or circuit. Is it okay? So best is to represent or express the given function in SOP. Even if POS is given, you can convert it into SOP. Is it okay? Yes, sir. So first is to express the given function in SOP, sum of product, so that your expression will be in the form of and or. Your expression will be in the form of and or. Next, to implement n variable function, connect n minus 1 variables onto the select line. To implement n variable function, connect n minus 1 variables onto the select line. To implement n variable, connect n minus 1 variables on select lines. Next, list the input of mux in 2 different rows. I will let you know. Just write down first. List the input of mux in 2 different rows. Circle all the minterms of a function. Now inspect each column separately. If 2 minterms are circled, apply logic 1. If 2 minterms are not circled, apply logic 0. If 2 minterms are circled, apply logic 1. If 2 minterms are not circled, apply logic 0. If 2 minterms are circled, apply logic 1. If 2 minterms are not circled, apply logic 0. If only one minterm in a column, is circled, then the front value of its is a corresponding input to multiplexer. Then its front value of it is a corresponding input to multiplexer. Now let's try to understand how to find out the minimized, how to find out the inputs and select lines to implement any function. Okay. Yes, sir. Please observe, beta ji. Please observe, beta ji. Suppose if we are interested to design a any function, whatever function you want, you can design. Okay. So let us suppose you want to design a function majority bit detector circuit. Okay. So construct truth table of 3-bit majority detector circuit. Construct truth table of 3-bit majority detector circuit and implement it by using 4x1 size mux with all possible select line condition. Okay. Suppose if I am interested to design a 3-bit majority detector circuit. If the majority in the 3-bit is 0, we will get 0. If the majority in 3-bit is 1, we will get 1. Is it okay? So we want to design a 3-bit majority detector circuit. First, construct a truth table and then implement by using 4x1 size multiplexer. 4x1 size multiplexer with all possible select line conditions. Okay. So what we want to design? Please observe, beta ji. So what we want to design? Sir, we want to design a 3-bit majority detector circuit by using multiplexer. So let us suppose the input bits are A, B, C. Let us suppose the input variables are A, B, C and output is Y. Is it okay? So we have a 3-bit majority detector circuit. So a 3-bit majority detector circuit. We know about the inputs and outputs, beta ji. Yes, sir. Now we know about the inputs and outputs. Next is to construct truth tables. So please observe, I am constructing a truth table. So how many possibility with the 3 variables? A total 8 possibility with the 3 variables. So 8 possibility with the 3 variables, considering A as a MSB and C as a LSB. So we can represent the possibilities in terms of binary conditions as 000. Any one of them is high. Any 2 of them are high. Or all are high. When you observe this, na, please see, beta ji. And now today only you can do any question based on the multiplexer. Okay. Now please observe. Only one enable pin is left out, and that enable pin we will see in the decoder and encoder. And the same enable pin is sometimes used in the multiplexers as well. That we will see in the encoder and decoders. Now please observe, this is the binary of 0, binary of 1, binary of 2, binary of 3, 4, 5 and 6 and 7. Now can you please tell me what will be the binary conditions you want? Majority bit detector 0, 0, 0, 1, 0, 1, 1, 1. So it means 3, 5, 6, 7. What we are getting? 3, 5, 6, 7. We are getting 3, 5, 6, 7 as a binary output high onto the binary condition of 3, 5, 6, 7 with A as a MSB and C as a LSB. This is the majority 3-bit majority detector circuit. We want to implement by using multiplexer. So what are the possibility? Out of A, B, C, we can choose any 2 onto the select line. Out of A, B, C, we can choose any 2 onto the select line. Yes, sir. So let us first discuss with AB onto the select line or with BC onto the select line. Okay. So we can choose any 2 onto the select line because we have to implement by using 4x1 multiplexer. So we want to implement the function desired function by 4 cross 2 multiplexer. Okay, 4 cross 1 multiplexer, and 4 cross 1 multiplexer will have 2 select line. Is it okay, beta ji? Yes, sir. So I am interested to find out what are the inputs needed. Now onto the select line, if we are going to choose BC, then out of B and C, which one is MSB? If C is a LSB, then out of B and C, B is onto the select line 1 and C is onto the select line S0. Is it okay? Out of B and C, if we choose, B is onto the MSB and C is onto the LSB. Is it okay? Yes, sir. Now what we can give input to the multiplexer, we can apply here either A bar, 0, 1. So we have 4 possibility that we can apply onto the input pins. So as per the information we have from the steps to implement any function by using multiplexer, first of all we have to implement the given function in SOP. So now we have a function 3, 5, 6, 7 in SOP. Next, if to implement n variables, connect n minus 1 variables to the select line. Already we have 3 variable A, B, C, out of which 2 variables we are going to connect onto the select line. Is it okay? As per the defined size. List the input of mux in 2 different rows. Now please observe, I am listing the input of mux in 2 different rows. What we can apply at the input, either A bar or A. We can apply either A bar or A. So I list the input of mux. List the input of mux in 2 different rows. List the input of mux in 2 different rows. Please observe very carefully, beta ji. List the input of mux in 2 different rows. Okay. So A bar and A, 2 different rows. Now please observe here, we have mux input 2 mux and input required 2 mux. Now please observe, beta ji, mux inputs are we have I0, I1, I2 and I3. These are the mux input pins. Is it okay? Yes, sir. Where we can either apply A bar or A. Is it okay? Yes, sir. Now please observe, what are the minterms of a function in which we are getting A bar? What are the minterms of a function in which we are getting A bar? So if you observe, the binary of 0 will have A bar. The binary of 0 will have A bar. Is it okay? A bar, B bar, C bar. The binary of 1 will have A bar, B bar, C. So the min term of 1 have A bar. Min term of 2 have A bar. Min term of 3 have A bar. So now I am started with A bar. So min term of 0, A bar. So A bar, min term of 0 contains A bar. So 0 is represented in front of A bar. In the same way, min term of 1 contains A bar. So 1 is in front of A bar. Min term of 2 contains A bar. Min term of 3 contains A bar. Min term of 4 contains A. Min term of 5 contains A. Min term of 6 contains A. Min term of 7 contains A. So those min terms which contains A are in front of A, and those min terms which contains A bar are in front of A bar. Is it okay? Very good, beta ji. Great. IIT Bombay first year. CS BTech. Very good, beta ji. Great. So since you are now reached to your MTech program, hoping you will guide to your juniors as well. Okay. Your journey, and also lot of study is needed there as well. So your BTech study is going to be used there. Okay. So please try to cover the maximum part. It's not the war get over once you have reached to the Bombay IIT or Madras IIT. It is just the war begins. Okay, because now first fight is to get in a college, and then next fight is to have the best package among them who are in your level in your college. Is it okay? So great. It's great that you have reached there. Very good, Betaji. Bless you for your futures. And also, I wish that you will get all your success in your life. Now, let's come back to this. So, we have to observe each of the columns separately now. List the input of mux in two different rows. Everyone, please observe, Betaji. List the input of mux. List the input of mux in two rows. Now, circle all the min terms of a function. So, the function what we want to implement is 3, 5, 6, 7. We need to circle all the min terms of a function. 3, 5, 6, 7. Now, inspect each column separately. If two min terms are not circled, apply logic 0. If two min terms are not circled, apply logic 0. Input required to mux I0 is 0. Input required to mux I1. If only one min term is circled, then its front value is the corresponding input to multiplexer. How many of you able to understand, Betaji? If only one min term is circled, then its front value is the corresponding input to multiplexer. If two min terms are circled, apply logic 1. So now we know what is the input needed with BC onto the select line. What is the input needed with BC onto the select line? So we need to apply 0 on I0 pin, 1 on A on I1 pin, A on I2 pin, and 1 on I3 pin. Let's verify whether it will work or not. Let's verify whether it would work or not. So, as per what we are getting, let's verify. So we have, sir, I0 pin, I1 pin, I2 pin, I3 pin. We are getting here 0, A, logic level 1. And sir, onto the select line S0 and S1, we are getting BC. So because of the select line, we have B bar, C bar, B bar, C, BC bar and BC. Yes, sir. Now, we all know that this is going to be multiplied with the input pins and entire is going to pass through the OR gate. So we are getting onto the output Y as A, B bar, C, because the first one is multiplied with 0, so 0 only, plus of A, B bar, C, plus of A, B, C bar, plus of BC. So whether this is a desired function, sir, the given function is not a canonical function. Multiplexer may give an intermediate expression. In order to identify the desired function, we must need to write a canonical. In order to check what actual function is implemented, we need to write a canonical. So A is missing, we need to write A bar. So we will get A, B, C plus of A bar, B, C. So this is the binary of 3, binary of 7, binary of 6 and binary of 5. So the function implemented by the circuit is 3, 5, 6, 7. The same function we want to implement as a majority bit detector circuit. How many of you able to understand? The case 1 with BC as a select line. Someone may started thinking that instead of selecting BC, let's select some other two variables. So consider case 2. Case 2 with AC on select line. Instead of BC, if someone is taking AC onto the select line. So please observe, Betaji, we have S0 and S1. I0, I1, I2, I3 onto the I0 pin, I1 and I2 pin. We have to identify what we need to apply. Okay. Yes, sir. Great. Now, can you please tell me, out of A and C, which one is MSB? Out of A and C, A is a MSB, so must be applied onto the MSB pin of select, and C must be onto the LSB pin of select. Is it okay? Now, we can apply B and B bar. What are the inputs we can apply? B and B bar. So, list the input of mux in two different rows. List the input of mux in two different rows. Now, inspect each column separately. I0, I1, I2, I3. So, I0, I1, I2, I3. Now, please observe. In the min term of 0, we get B bar. Yes, sir. Please observe here. In the min term of 0 and 1, we get B bar. 0, 1, we get B bar. So in the min term of 0, we get B bar. In the min term of 1, we get B bar. But in the min term of 2, we get B. In the min term of 2, we get B. In the min term of 3, we get B. In the min term of 4, we get B bar. In the min term of 5, we get B bar. In the min term of 6, A, B, C bar, we get B. In the min term of 7, A, B, C, we get B. The numbering is very important whenever you are finding out the input pins to the multiplexer and the select conditions are given. Numbering is very important based upon the MSBs and LSBs. Now what function you want to implement? 3, 5, 3, 5, 6, 7. What we are getting? We are getting 0, B, B, 1. So if you apply 0, B, B1, your function will get implemented. How many of you able to understand, beta ji? How many of you able to understand this? So input I0 needed B0, input I1 needed B, input I2 needed B, input I3 needed 1. Someone is saying, sir, instead of taking BC or AC as a select line, I am interested to take AB onto the select line. So let's have a case number 3. Okay. So with AB on select line, with AB on select lines, with AB on select lines, out of A and B, which one is MSB? Out of A and B, A is a MSB and B is a LSB. Yes, sir. So we have I0, I1, I2, I3, and sir, we have 4 cross 1 mux. Can you please tell me? Haji beta, can you please tell me what is the input possible in this case? Sir, the input possible in this case is C or C bar. So list the input of mux in 2 different rows. List the input of mux in 2 different rows. Now inspect each column separately. So for inspecting each column separately, please observe we have I0, I1, I2, I3. Now if you observe C bar, what are the minterms in which we are getting C bar? If we take the binary of 0, we get A bar, B bar, C bar. So binary of 0 have C bar. Min term of 1, A bar, B bar, C. Min term of 1 contains C. Min term of 2 contains C bar. That is 2 means A bar, B, C bar. Min term of 3, A bar, B, C. Yes sir, C. So those min terms in which we are getting C bar, they are in front of C bar, and those min term in which we are getting C are in front of C. Is it okay? Now circle all the min terms and inspect each column separately. 3, 5, 6, 7. It is not fixed that always we will get the same. This is a unique function in which we are getting same. Okay. So 0, C, C, and 1. So if you apply 0, if you apply C, C, and 1, your function will get implemented. How many of you able to understand, beta ji? How many of you able to understand up to this part? How many of you able to understand up to this part? Please let me know by writing in the comment section, beta ji. How many of you able to understand up to this part? Can you answer this question? Can you answer this question? We have A, B, C, D. I'm just writing the options you have to select. Okay. So please let me know which of the following is correct. 2, 3, 2, 3, 4, 6, 7. Which of the following is correct? Can you please tell me which of the following option is correct? So sir, basically we know A bar A 0, 1, 2, 3, 4, 5, 6, 7, because A is the MSB and C is the LSB. Because in A, B, C, they haven't mentioned MSB and LSB, so we will consider A as a MSB and C as a LSB. In case if they give, we will consider accordingly. Okay. So we have I0, I1, I2, I3. Numbering is very important. You all can see that A will remain low from 0 to 3 and remain high from 4 to 7. So 0, 1, 2, 3 in front of A bar and 4, 5, 6, 7 in front of this. Now what is the function? 2, 3, 4, 6, 7. So we are getting A0, 1, 1. A0, 1, 1, option number C. How many of you able to understand up to this part? Please let me know by writing in the comment section, beta ji. Can you answer such kind of questions? Great, sir. Can you answer such kind of questions, beta ji? Please let me know by writing in the comment section. Can you answer such kind of questions? Great. So we have one question from the Indian Administrative Services as well. Here we have to observe the most suitable size, and first of all we have to implement the function ABCD, and the function is given by using 8 cross 1 with the best select line possibles, and then we have to compare which size is preferable, whether 8 cross 1 or a 4 cross 1, which is a more better size to implement this particular function in terms of cost and speed, if both are the consideration. Okay. So how to implement by using 8 cross 1? Please observe, very important. How to implement by using 8 cross 1 mux? By using 8 cross 1 mux. If we have to implement by using 8 cross 1 mux, then what are the different possibilities we have? We can choose, sir, either BCD, ABC. We can choose BCD, ABC, ABD or ACD. There are multiple options possible. So suppose if someone is choosing BCD, so we have A bar A, someone is choosing B bar B, C bar C and D bar D. So total 4 possibility, and I am observing all of the 4 possibilities so that we can choose the best possible onto the select line. Is it okay? So I am interested to have a selection of best possible select line. Okay. Yes, sir. Now we have a I0 pin, I1 pin, I0 pin, I1 pin, I2 pin, I3 pin, I4 pin, I5 pin, I6 pin, I7 pin, please give me a small time so that I can conclude this topic as well. Okay. I'm about to conclude this topic. So we have I0, I1, I2, I3, I4, I5, I6, I7. Okay. So 8 cross 1 will have 8 or total possibilities of 8. I0, I1, I2, I3, I4, I5, I6, I7. Okay. Now please observe, beta ji, numbering is very important. So for A as a input, if we have BCD onto the select line, what is onto the select line? Here we have BCD onto the select line. BCD on select. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. From 0 to 7, A will remain low, and from 8 to 15, A will remain high. If we have A, C, D onto the select line, then B will have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Those minterms in which we are getting B bar, those are in front of B bar, and those minterms in which we are getting B are in front of B. Is it okay? Maybe someone has taken a select line as A, B, D. If someone has taken a select line A, B, D, then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. How would I know 0, 1, 2, 3? Because I know C is on the 2 to the power 1 position, where on every second time logic level is going to change. Is it okay? In the same way, if we talk about D is a LSB. So LSB is changing on every successive number. So if we have A, B, C onto the select line, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Is it okay, beta ji? Yes, sir. Now, if we talk about this, then what is the condition of I0, I1, I2, I3, I4, I5, I6, I7? Let's have a discussion for this. If we have BCD as a select line, what is the function we want to implement? 0, 1, 0, 1, 2, 0, 1, 2, 4, 0, 1, 2, 4, 6, 7, 0, 1, 2, 4, 6, 7, 9 and 12. 0, 1, 6, 4, 7, 9 and 12. So what are the output, beta ji? We have, sir, A bar. We have, sir, logic level 1. We have A bar, logic level 0, 1, 0, and we have, this is your A bar, and this is your A bar. How many of you able to understand, beta ji? If we have a select line, as ACD, then the function is 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 6 and 7. For this 0, 1, 2, 3, 4, 6, 7, 9 and 12. What we are getting, beta ji? We are getting, sir, logic level 1, logic level B bar, logic level 1, logic level 1, logic level B, logic level B bar, 0, 0. If we talk about ABD as a select line, then ABD as a select line, then we have 0, 1, 2, 3, 4, 6, 7, 9, 12. Then we have, sir, logic level 1, logic level 1, logic level 1, logic level C, then 0, then logic level, we have C bar, then C bar, then 0. And if we have A, B, C onto the select line, then 0, 1, 2, 3, 4, 6. 0, 1, 2, 3, 4, 6, 7. 0, 1, 2, 3, 4, 6, 7. 9, 12. 9 and 12. Is it okay? 0, 1, 2, 3, 0, 1, 2, 3, 4, 0, 1, 2, 3. Okay, I have missed 3 here, na? 0, 1, 2, 3 is also there. So on to the I3 pin, we are getting A bar. 0, 1, 2, 3, 4, 6, 7, 12, 9, 12, 6, 7, 9, 12, 6, 7, 9, 12. So this function would be great if we have 5 and 13 also included. Okay, no issue. Whatever given, you have to choose that only. So if we have ABC onto the select line, if we have ABC, because nowadays we have a multiple select question. In a multiple select question, they may give the option along with the select lines. Is it okay? So please be ready with that. In this particular case, since we are getting a bar in every, so we can choose any one of them. However, suppose if we are getting only logic zeros and logic ones and we are not getting any complement, then that would be more preferable comparative to the other select lines. Is it okay? This function will become great if we have 13 also, 5 and 13 also included in the function. If we include 5 and 13, then this function will become more like we will choose A, B, C onto the select line and D onto the input. But okay, whatever given, we have to go accordingly. So in this case, we can have any of the select input condition. 1 D bar 1 D bar 1 D 0 D bar 0. So you can choose any of the condition, because in this all will using C bar, A bar, B bar. In all we need a bar as well. In some, if in some of the particular function, if we don't need the complement, then that would be the best possible combination that we can choose. Is it okay, everyone? Please let me know by writing the comment section, beta ji. Great. We also want to implement by using 4 cross 1 size. We also want to implement by using 4 cross 1 size. We also want to implement by using 4 cross 1 size. So how to implement by using 4 cross 1? Now please observe, beta ji. How to implement by using 4 cross 1? How to implement by using 4 cross 1? If we talk about 4 cross 1, we have a function, and in this function we want to implement by using 4 cross 1. So we have two possibilities. One possibility is either we can have AB, BC or CD onto the select line. First I am choosing AB onto the select line, and then I am choosing CD onto the select line. Is it okay? So we have 1, 2, 3, 4 inputs. We have 1, 2, 3, 4 inputs. This is a 4 cross 1 mux. This is also a 4 cross 1 mux. Okay. Yes, sir. So here we have I0, I1, I2, I3, I0, I1, I2, I3. Now for 4 cross 1, it's a special case, best to go with a K map. Okay. If you observe a K map, with AB onto the select line, A bar, B bar, A bar, B, AB, A, B bar, C bar, D bar, C bar, D, CD, CD bar. Okay. And numbering is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Okay. This is a special case, beta ji. More than that, they are never going to be asked. So this is the maximum that they can go. Please observe. We have a function 0, 1, 2, 3. 0, 1, 2, 3. So 0, 1, 2, 3. I'm just putting logic level 1 where we are getting high. This is in a SOP form. So 0, 1, 2, 3. 0, 1, 2, 3. Then 4, 6, 7, 9, 12. 4, 6, 7, 4, 6, 7, 9 and 12. Is it okay? Yes, sir. Now please observe 0, 1, 0, 1, 2, 3, 0, 1, 2, 3, 4, 6, 7, 9, 12. 0, 1, 2, 3, 0, 1, 2, 3, 4, 6, 9, 7. Now please observe here. We can choose a smaller size of the logic gate along with some logic, smaller size of the multiplexer along with some logic gates. If I choose this as a select line I0 will have a select input A bar, B bar. I1 will have select input this. I3 will have a select input AB, and I2 will have a select input this. Then if we are going to choose like this, then only we can do with a horizontal pairing. It means out of C and D, what we have to consider. So here we have logic level 1. Here we have one this pair and another this pair. So the corner pairs in C and D will give you D bar, and the last two pairs will give you C. So we can apply C plus D bar. Here this is alone, so alone will give you C bar D bar, and here we have alone. Alone will give you A. AB is already there. C bar D. C bar D. It means the function can be implemented, but when we are going to implement a function, along with the function we need logic gates as well. In the same way, if someone is considering this CD as a select line, then I0, I1, I2, I3 pin is like this. Is it okay? And now only vertical pairings are allowed. So we have 0, 1, 2, 3, 4, 5, 4, 6, 7, 5 is not there, na? 12 and 9. Now in this we have one pair possible this, one pair possible this, and this will give you A bar plus B. So we have A bar plus B. Only vertical pairings are allowed here. So already C bar D is onto the I1 pin because of the select line function. Is it okay? So here we have B bar, and here we have B A bar, and here we have A bar. Is it okay? So it means if we compare the two, then this will have a better option because it has only one A bar plus B. So we need A bar plus B onto the I0 pin. So we have A bar plus B, and here we need B bar, here we need A bar, and here we need A bar. So your function will get implemented by using 4x1 size multiplex. But definitely, because the delay is increasing, so definitely 8x1 size will be a preferable comparative to 4x1. Is it okay? If the variables and their complements are available, then 8x1 size with any of the select line will be a better solution comparative to 4x1. Because if we are going with 4x1, although the number of logic gates decreases, but the delay is increasing. Is it okay? If you observe here we have logic level 1, then we need D bar C. So D bar plus C. Is it okay? And we need one AND gate, na? We need one NOR gate. Which gives C plus C bar plus C bar D bar, and we need one AND gate with a one input bubbled, that is C D. In case if all the variables are also available, then we can use simply AND gate instead of going with a NOR gate and a bubbled OR gate. Is it okay? How many of you able to understand how to implement any function? Now this size will be good in case if the function is such that we can only apply here without any logic gate the function. If it is possible to apply, then that will be a better option. How many of you able to understand, Betaji? How many of you able to understand? See, when we are considering AB onto the select line, then A bar B bar is available because of the select line. A bar B is available, A B bar is available, AB is available onto the select line. So we will only go with the horizontal pairing to find out of C and D what we need to apply. In the same way, if we have CD, then C bar D bar is available, C bar D is available, CD bar is available, CD is available. Now only we have to identify out of A and B. So only vertical pairings are allowed. How many of you able to understand this function perfectly, Betaji? Please let me know by writing in the comment section. So I just wanted a last question to ask you. Please see, I'm giving some questions to you as a homework. So this is a homework question for you, and hoping you can easily find out, because in the previous we have designed the question in the same way. We have some logic gates and all. So I'm giving you some questions as a homework. Please try these questions, and you can discuss these questions on the Telegram. So this is your Telegram only. I'm just giving a Telegram detail as well. You can just simply scan and connect onto the Telegram. So this is your Telegram link. So you can connect to the Telegram to discuss any question that I am giving to you as a homework. You can just take a screenshot and post in the post back to the Telegram group. Whatever you are not able to solve, I will help you. Is it okay? So these questions I am giving to you as a homework and hoping you can easily do all these questions. You can easily do all these questions. So I am giving some more questions to you as a homework because this is very important topic, especially in gate. Logic level 5 means logic 1 and ground, it is representing ground. Is it okay? So you can easily do these questions. I am just giving some of the questions to you as a homework and hoping all of you can easily solve these questions. Is it okay? One very important part, just one very important point. Suppose if we have a function, suppose if we have a function sorry for extending the class because I just want to have a maximum coverage so that you can have a better options to solve. Can you please answer for this particular one? What is the best size? Okay. So we have a function a, b. I'm just representing. SOP function is represented. SOP function is represented in the K map shown below. The function y with output logic 1 is shown in K map. Find the best size in terms of cost, and delay of mux to implement function y. Okay, so the sizes are given to you as 4 cross 1 A, B 8 cross 1, C 2 cross 1, and D both A and B. Very important point. Consider variable and their complements are available. So if the variables and their complements are available, then you have to tell me if the complements and their available, then their complements and their variables and their complements. It means A and A bar both are available. So can you please tell me what will be the best size for this multiplexer? See, we have total 4 variables. So out of 4 variables, we can connect n minus 1 variables. So definitely we can use 8 cross 1. There is no doubt in this, and we all know how to use 8 cross 1. But can we use 4 cross 1 as well? It will have a lower in cost and with the same delay possible if we observe only horizontal pairing. So if we only observe the horizontal pairing, what happened? With the only horizontal pairing, out of C and D, we have C bar. This is logic level 1. Here we have D. This is we have logic level 1 or logic level 1 C. So if we are going to implement by using 4 cross 1 with a I0 as a this pin, I1 as this pin, I2 and I3, it means if we choose AB onto the select line, then only horizontal pairings will be there, and the function can be implemented with C bar 1 D C. So it will be far better to go with this, because the multiplexer of 4 cross 1 will have lower cost. It can be implemented by all of them, but the most lowest cost with the same delay possible is 4 cross 1. So we must have to choose 4 cross 1 instead of going with the 8 cross 1. How many of you now able to understand, Betaji? Great. So that's all for this class. Hoping all of you have enjoyed this class so far. And rest we will discuss in the upcoming class about the demultiplexer. So please share your doubts, if any, on the Telegram, on your Telegram, Varun sir, PW. Hoping you have enjoyed this session a lot. Again, sorry for taking 30 minutes extra, but hoping you have enjoyed this class so far. Thank you everyone. Lots of love. Good night.